Okay, so guys, let's look at this other question coming from 2018, equation on vectors. Okay, so we are told to say, given that um, AB is equal to vector A, AD is equal to vector B, BC is equal to vector, sorry, 2 vector A, 2 vector B. Okay, this one's supposed to be vector B, 2 vector B. Okay, this one. Okay, and then we are told to say AE to AC is equal to 1 to 3. So what it means is the first term AE it's 1. Then AC is what? 3. So meaning from A to E, its ratio it's 1. Then from A to C, it's 3. Now we have a 1, so meaning this one's supposed to be what? 2. Such that when you add 1 plus 2, you get 3. From A to C, we are told to say from A to C, it's what? It's 3. Okay? Look. A, E, it's what? 1. Okay? Then AC, it's what? It's 3. Okay? So from A to E is 1. Then from A to C it's 1 plus 2, which is 3. That's the meaning. Very important. Okay? So let's move on now. The first one we are told to say express in terms of A and or B. Okay? Question A, AE. They want us to find AE. They want us to find AE. Question A. So solutions. Okay? Question A. They want us to find A, E. From A to what? To E. Now, how can we move from A to E? A, E. So AE, we can say AB plus BE. But the problem is we don't have BE. So it's going to become difficult for us to find this one. Okay? So the best way we can find AE is by saying, since we know that AE it's 1 as a ratio, so AE it's 1 over 3 of AC. Okay? This one, AE. So AE, it's 1 over 3 of AC. And then EC, this one becomes 2 over 3 of AC. Okay? Now we're told to find AE. So we're going to use this one. So AE is equal to 1 over 3 of AC. Now do we have AC? Do we have AC? No, we don't have AC, but we can find AC. You can find AC. We know how can we move from A to C. Okay? So for us to move from A to C, we can say AB plus BC. Okay? So we say AE is equal to 1 over 3 of AC. Now AC can be found by saying AB plus BC. Okay? From A to C, you can say AB plus BC. Okay? So AE is equal to 1 over 3. What is AB? AB is vector A plus, what is BC? BC is 2 vector B. Okay, so AE is equal to, can distribute, it's like you have 1 over 3 multiplied by vector A, you get 1 over 3 vector A. Then plus 1 over 3 times vector, 1 over 3 times 2 vector B, we're going to get 2 over 3 vector B. So this is our answer. Okay, let's look at this other one. BE. How can we move from B to E? BE. So BE, you can say B A plus A E. B A plus A E. Okay. So question B. Question B, they want us to find B E. Okay. So it's a B E. You say it's B A plus A E. Okay. So B A plus A E. Okay. So B E is equal to, now do we have BA? BA it's negative vector A. Okay, since we are moving against the direction, we are going to have negative vector A plus, do we have this one? AE, yes. This is our AE. So our AE is what? 1 over 3 vector A plus 2 over 3 vector what? B. So B E is equal to, you can say over 1. And then what is our lowest common denominator of 1 and 3? It's what? 3. So 1 into 3, it's 3. 3 times negative vector A, you get negative 3 vector A. Okay? And then plus, okay? 3 into 3, it's 1. 1 times vector A, you get vector A. Okay? Then plus 2 over 3 vector what? Vector B. So B E is equal to negative 3 vector A plus vector A. We're going to get negative 2 vector A over what? Over 3 plus 2 over 3 vector B. Okay. Then B E is equal to, we can start with a positive and say 2 over 3 vector B minus 2 over 3 vector A. So this is our answer. Okay, for question B. Then let's go to question C. Now question C, the question is, they want us to express BD. BD. Where is BD? BD from B to D. Okay? From B to D. Okay? So how can we move? So from B to D, you can just say B A plus A D. As simple as that. So I'm sure this is very simple. It is very simple. It is what? B BD. BD. So BD is equal to BA. BA. Okay? BA plus AD plus AD. Okay? So I can say BD is equal to, what is BA? BA, we're moving against the R, which is negative A. So plus AD, it's what? AD is vector B. So BD is finally starting with the positive B minus A as vectors. Okay, so we're done. Let's look at this other question. Question Roman numeral what? Roman numeral 2. Hence or otherwise, show that the points B, E, and D are collinear. Okay, so they want us to show that these 3 points, they are on the same line. Okay, B, D, sorry, B, E, and what? D. Okay, let me just get a piece of chalk, guys. Okay, that is a piece of chalk. Okay, so let's move on. Now, in this case, what they want is they want a situation like this. Just do this. Okay. So we're going to say, since they're saying show that these 3 points are collinear, so we're going to say BD. Okay, BD is equal to, let's say, let's consider this one BE. Let's consider this one. Okay, so let's say if these are collinear, what it means is, if let's say we find a scalar, let's find a scalar such that if we multiply a certain scalar by this, we need to produce this. Okay, meaning these are supposed to be what? Equal. Okay, so what we're going to do is we're going to find a scalar. Let's find a scalar. So let's say a scalar is going to be, let's say h. Let's say h is our scalar. So let's find our h. Okay, such that if we multiply that scalar by this, we need to produce this. Okay, we need to have BD. So let's move on. So now, do we have BD? Do we have BD somewhere? BD here, this is our BD. So we're going to say BD, it's B minus A. This is our BD. Look, BD. Okay, this is our answer. So why there's BD, I've substituted with this answer, is equal to, let's say, H. Do we have our BE? Yes, this is our BE. This is our BE. So BE it's 2 over 3B plus, is it plus or minus? Minus 2 over 3 vector A. Okay. Then we can now distribute this H. We're going to multiply H by what is inside. So first we're going to maintain B minus C A is equal to, so when we multiply now, we're going to have H times 2 over 3 vector B. We're going to have 2 over 3 H vector B. Again, we're going to multiply H times negative 2 over 3 vector A. We're going to have negative 2 over 3 H vector A. Okay, so having done this, what we're going to do is we're going to equate. Look, this one has got H, so this one has got B, this one has got B. We have a B, we have a B, we have an A, we have an A. Okay, so we have B, B, A. So meaning we are going to equate this one to this, then this one to this other one. Okay, because these are like them. So we're going to have B, and we're going to have what? B. Okay, B is equal to what? 2 over 3 H vector B, and then on this other side you're going to have what? Negative A is equal to this, negative A is equal to this, because there is A, we have A is equal to negative 2 over 3 H vector A. Okay, so now at this point what we are going to do is we can get rid of what? These 3. We can eliminate them, just separate these 2. We can eliminate these 3. Now how do we eliminate these 3? So we are going to multiply by 3 this side. Okay, now since we have an equal sign, if we multiply by 3 this side, you also multiply by 3 even on the other side. Okay, such that these 3 and these 3 are going to cancel. Then here are going to have 3 times B, you're going to have 3B is equal to 2 times HB, you're going to have 2H vector B. Okay, then for us to remain with H, which is this scalar, because we want this scalar, we need to divide both sides. Divide both sides by 2 vector B. Inside say 2 vector B, such that these 2 and these 2 are going to go. This B and this B are going to go. This B and this B are going to go this side. We are going to remain with H. H is equal to 3 over 2. Okay? Let's try to find H on the other side. So on this other side, again, we can get rid of this. Just move this side. People can see. Okay? So on this other side, let me just do this, guys. Just a minute. Okay. So on this other side, we're also going to get rid of this 3 by multiplying by 3. This side multiply by what? By 3. Okay, so that this 3 and this 3 can go in. Okay, then I'm going to have 3 times negative a get negative 3 vector a. Okay, is equal to, then you have negative 2 h. Okay, vector what? Vector a. Okay, then for us to remain with h, we're going to divide both sides by negative 2 vector a. Negative 2 vector a. So that this negative 2 and this negative 2 can go. This a and this a can go. Then in this side, this a and this a can go. Negative or negative is positive. So we're going to mean with h. H is equal to 3 over 2. So this is our scalar. Okay, this is our scalar. Now let's verify if these two are collinear. Let's verify if these 3 points are what? Collinear. Let me just move the board this side so that people can see that side. Okay. So let's try to verify if these are collinear. So we said let's do this. Say BD is equal to HBE. Okay, this is what we said. Okay, now BD, it's B minus A. Okay, is equal to, what is our H? Our H is 3 over 2. Okay, what is our BE? What is our BE? BE, remember, BE was what? 2 over 3 vector B, this one. Okay, BE was 2 over 3 vector B minus 2 over 3 vector A. Okay, so we're going to maintain B minus A, so that when you multiply now, 3 times 2 vector B, we get 6 vector B over 2 times 3, we get 6. Positive times negative, negative 3 times 2, get 6 vector A over 2 times 3, get 6. Okay, so B minus A is equal to 6 and 6 are going to go. We're going to win with vector B minus 6 and 6 are going to go. We're going to win with vector A. You've seen? So these are equal. So you say the points B, E, and D are collinear. Since B D is equal to 3 over 2 B E. Okay, so this is the way you answer, guys. As simple as that. Okay.